Hi there, this is the IPS Project. I'm Richard, and today I'm going to have a look at high pass filter. This is a very simple device. It's two components, a resistor and a capacitor. That's why it's an RC passive high pass filter. I'm going to use a 1K resistor in here, and I'm going to change the capacitance, because what I want to look at is how the cutoff point is going to change depending upon that capacitor. So supposedly with a high pass filter, anything below the cutoff point I'm going to not get, and anything above that I will get through. Equation, very simple. This equation is the same as a low pass filter. Frequency is turned by 1 over 2 pi RC. Very simple. Can't go wrong with that, can we now then? I've drawn a little chart just to show what I'm going to be expecting to get. Frequency against amplitude. So that would be my cutoff point. So at my cutoff point, I'm expecting that I will get all of the signal come through above that frequency, and anything below it will be attenuated. Now, as with any of the filters, you find that at the cutoff point you're not getting the full signal. There's this area here before you get to the full signal. Depending on the frequency you have, it's always slightly lower, and it's usually -3 dB from your input signal. So it's already attenuated slightly at that point. There is equations you can use to calculate that, but that's not what I'm looking at. I'm just going to look at changing this capacitor will change the frequency at which my cutoff point will shift. So again, it's a case of if I change the capacitor, will I have a lower cutoff point or a higher cutoff point? So I'll have less low frequencies coming through and more higher frequencies, or whatever it's going to be. So that's what I'm going to do. Change the capacitor, see what my cutoff point is and what I'm going to get on the output. So up there on the output. So let's have a look at that. I've got it set up on the bench here, so let's have a look. Okay, so here we have it on the breadboard. I've got my I've got a 1 microfarad capacitor, and this is my setup. It's going to come in through this capacitor, and then this is my output, that's my input, and that's the resistor to ground. So this capacitor is going to be determining exactly what frequency I'm going to be cutting off at. Now, I've decided to go with this the same as I did with the low pass filter, same sort of capacitance. I'm going to have a 1 microfarad, a 220 nanofarad, 100 nanofarad, a 47 nanofarad and a 15 nanofarad capacitor in there, and I'm going to see what frequency cutoff point I'm going to get and how it affects what I'm going to get through. So starting with the 1 microfarad, let's turn this on. My function generator, by the way, is going to start with 500 Hertz, half a volt, and that's going to be my main sort of setup. But first of all, let's just pan this camera up to the scope. So that's where all the interesting stuff's going to be. I think all I need to do now is to turn on the channel, the function generator, and there you go. You can see we've got the signal. I've got 500 Hertz. Now with the 1 microfarad, it's telling me that my cutoff point is 159 Hertz. So let's change that. 159 Hertz. There we go. And as you can see, I'm getting quite a lot of the signal through, but not all of it. Again, we've got this loss from the original signal. I'm getting about -3 dB, should be. I haven't calculated, I'm not looking at that today anyway. But there is a phase shift, and the phase shift is back from the original signal its phase shift, well, I don't know how much it's shifted back. What about 45 degrees shift, minus shift? I don't know, not looked at it. Again, there's equations to work this out, not what I'm looking at today. Anyway, let's turn that signal down, because supposedly less signal, it's going to be more heavily attenuated. And as I turn it down, we're now at 100 Hertz. Yeah, we're getting less signal. We just get more on the screen, so it's a bit more apparent. And as I turn that down, it really does start to attenuate it. And my input signal is now at 50 Hertz. That's effectively mains voltage. Well, 50-60 Hertz, depending where you live. You know, in the UK it's 50, in the States and other places it's 60 Hertz. But you can see my output signal is definitely attenuated because the cutoff point is 159 Hertz. So yeah, we're going to get some loss. But above that, just turn this up. Take us all the way up to, I don't know, we'll take it back up to the 500 Hertz. 500 Hertz, I'm getting pretty much all of the signal through because I'm above that 159 Hertz cutoff point. So let's turn that off and change the capacitor. Now, as I said, I'm now going to use a 220 nanofarad capacitor. I'm not going to try showing it because it'll never focus at this range. Right, 220 nanofarad. So let's turn the scope on, and we've got some attenuation. Now, according to my calculations, the cutoff point, cutoff frequency for the 220 nanofarad is 723 Hertz. 723. And again, that looks very much like the last signal, but only that time I had a 1 microfarad and we were down at 159 Hertz, and now we're at 723, and we've got basically the same minus 3 dB loss on that signal. But if I turn that signal down, let me get more on the screen there. I'm just slowly turning this signal down, and it is decreasing. Let's turn that down a bit quicker. There we go. So below the frequency, I'm losing the signal. You know, I'll take it all the way down to, let's say, 100 Hertz. There we go. Got virtually no signal left in there. There is a certain amount, but not a lot really. But if I go above that signal of 723 Hertz, let's turn this up just a little bit quicker. 8, 9, 1 kilohertz. We're getting a lot more signal through. I keep cranking this up for the higher frequencies. At 2 kilohertz, I'm getting virtually all of that signal coming through, which is brilliant. So let's turn that off and go to the next capacitor, which I was going to use, which is going to be a 100 nanofarad. Get that in there. Right, so we've got the 100 nanofarad. Turn on channel 1, and now as you can see, because I'm always starting at the point of 500 Hertz, you can see the signal's already heavily attenuated, because the cutoff point this time with 100 nanofarad is 1.59 kilohertz. So let's just crank that up to 1.59 and have a look at that. And again, it looks just like it did before. There's my input signal, there's the phase shift on my output signal. It's about minus 3 dB from the original signal, so it always looks around about the same at the cutoff point. If we represent it in this way, you wouldn't know that you've got a different frequency, except for the fact that I've calculated it to be 1.59 kilohertz rather than 723 with the 220 nanofarad, or 159 hertz with the 1 microfarad capacitor. And again, if we turn that down, as we turn it down, we'll lose that signal and we'll attenuate it, because we don't want the low stuff. And there we are, all the way down at, let's get down to 500 hertz. Marvellous. But as I turn this up, turn up quite quickly, and we go past the 1.59, we start to get more of that signal coming through. Here we are at 5 kilohertz, and I see at 5 kilohertz we've pretty much got all of that frequency coming through, which is brilliant. So let's turn that off and change the capacitor now to a 47 nanofarad. So 47, yeah, there we go. Plug that in there. Turn on the frequency. I'm going to leave it at 5 kilohertz this time, and we'll see what it's like now. Perhaps I should change it and put it back to the 500 hertz, which is where we've been starting all the time. So we will start at the same point. 500 hertz, half a volt. And you can already see that we're massively attenuated that, because the cutoff point on this high pass filter with a 47 nanofarad capacitor is 3.38 kilohertz, and below that you can see that the signal is massively attenuated already. So if we now turn it up to 3.3 kilohertz, 3.38p, a little bit more precise. Again, turn it that way. When I set the scope like this, you look at it and go, it looks just the same as the other ones, and it should do, because there's my input signal, there's my output, got the phase shift, and it's about -3 dB, as I would expect. Only this time we're at 3.38 kilohertz rather than what the previous cutoff frequencies were. And if we now crank this up in frequency, we will get more of that frequency coming through. We've got 7, 8, 9, and now we're at 10 kilohertz, and at 10 kilohertz you can see we've got most of that signal coming through. So let's turn off that channel, signal, and swap it out for the last capacitor, which is my 15 nanofarad capacitor. Now I'm expecting with this, as I've calculated, that we're going to have a really high frequency cutoff point. So anything that's really low is not going to come through. So if I crank this all the way back down to the 500 hertz starting point, we are way below the cutoff point. So I'm expecting that at 500 hertz we will basically have nothing coming through. Just, yeah, you can see that we're already massively attenuating this, because my cutoff frequency is 10.6 kilohertz and we're at 500 hertz. So basically the low end signals, these low signals, are not going to come through. I know I've changed I keep changing the range. It's just so I can see it better, but we are at 500 hertz. This is measuring 2 milliseconds per division. Whereas when I crank the frequency up, I want to be able to see this better, so I'm going to have to change it to, I'm now at 200 microseconds per division, but I'm going to take that higher up to, I want it on, there we go, 20 microseconds per division. I'm just going to crank this frequency right up. So as you can see, I'm getting a lot more coming through, and as we take it to, I take it to 10.6, haven't I, to find my cutoff point. 10.6, there we go, at 10.6. Again, it looks just like the other frequency signals that we were looking at. We've got about -10 dB, same phase shift, but we are at 10.6 kilohertz now. Massive amount of frequency above what we were dealing with the higher capacitance. So let's just crank this up and see how far we go before we start getting all of that signal coming through. And we're getting a lot more, but it takes a lot more to get it up to there, because we've already attenuated the point where it attenuates. It quickly attenuates, but getting it up to having all of the frequency coming through, so it's equal to what the input signal in is quite hard. Partly to do with the way capacitors work. It's not allowing it to really get all the way up there. See, we're at 30 kilohertz now, and we're getting pretty much most of that signal through. So yeah, that's a good demonstration that the higher the capacitor, the more it allows the frequencies to come through, and the higher the capacitance, no, the lower the capacitance, like this 15 nanofarad, it only allows the higher frequencies to come through. So it's we're only getting, like with this one, 10.6 kilohertz is its cutoff point. Below that, it just doesn't allow it to come through. If I can whip this back down all the way to something like 5 kilohertz. You can see we're already starting to attenuate. We're at the cutoff point, 10.6 kilohertz, and below that it really attenuates it and takes out all of that low frequency signal, which is brilliant. So there you go. That's the high pass filter, effectively the opposite of the low pass filter. So exactly the opposite. Does it in exactly the same way, only we're dealing with the high frequencies coming through and not the low frequencies. Yeah, what more do I have to say about it? Nice and simple. So there you have it, a high pass filter. Very simple device, just a couple of components, and depending on what capacitor you put in there will determine what your cut-off point is going to be. So if you want a lot of higher frequencies going through, say like if you've got a little tweeter speaker, and you just want all the high stuff, then you put in the appropriate capacitance and get out all the high frequencies to that speaker. Very simple device, very easy to implement. So what else do you need to do with it? You know, it's just so simple, you know. But there you go. If you didn't like this video, you know what to do. If you did, give me a thumbs up, subscribe, and all comments are welcome. See you next time.